For this example, we're going to look at an archer's arrow. So again, this one follows a parabolic path, and we're given the formula negative 0.005 x squared plus 2x plus 5. So I've already started this problem, and sometimes it helps to just start with a graph. So even though it doesn't ask for the graph until the end, you may want to get it in your calculator to get a feel for what's going on. So let's open up our calculator and again clear out whatever's in there, and we're going to put a negative 0.005 and then x squared plus 2x plus 5. And then we're going to go ahead and do zoom 6. I think looking at these it's a little more difficult to get a feel for what's going on by just looking at the equation. So we're basically getting a straight line, so we know we need to go out a lot further. So let's go to our window, and again we can just guess 100, and then maybe start going by increments of 10, and then go up to x max, and then again go by increments of 10. And there's nothing wrong with the trial and error. So again, we don't see a lot going on, so we need to go out further. So let's try maybe 400 this time, and larger increments. Let's maybe go in increments of 25. Okay. And you also want to think about the graph paper, or the graph that you're going to make later, and try to match those increments with what's realistic on your paper. So here we go, and we'll see that it's awfully close over here. So let's just go out a little further with our x-axis. We're going to increments of 25, so let's change this to 425. And let's see if we can see our entire graph here. And we can see from beginning to end. So let's go back to our questions. So what is the maximum height of the arrow, and how far from its release does this occur? So again, maximum is asking you to find the vertex. So you can see here for A right here, the maximum height, we're going to use the vertex x equals negative b to a, and you'll see that, so this is where I'm looking at right here. So what I did was I plugged in 2 for b, and then negative 0.005 for a. And make sure when you put this in your calculator that the negative 2 goes in first, then divide, and then add parentheses around that denominator, and you'll come up with 200. So this is your x value, and then what you need to do is go ahead and plug it in for your y value to find your y value. So plug it back into this original equation up here and solve for y, and when you do that, you'll get 205 feet. Another way to do that is to do second calc, and again you're going to find the maximum. And then remember, when that coefficient of that a value is negative, it's also telling us that our parabola will open downward. And then we get to the right side of that point and hit enter, and you'll see here we have x is 200 and y is 205. So you can see I started creating my graph here. So I went in increments of 25. It looks like you'll have to do 50 to match the graph, or to have enough room on your graph on your paper. So 125, 225, sorry, 150, 175, 200. So I have 200 and about 205. So it's this point right up here is our max. And then the next question is asking for find the horizontal distance the arrow travels before it hits the ground around to the nearest foot. So we're looking for on the graph, we're looking for this point over here. so when it hits the ground. So y would equal 0. So when we know y is equal 0, if you can't factor the quadratic equation that you're given, it's telling us that we're going to go ahead and use the quadratic equation, which I've done right here. So I've made the substitution, and then when I put this in my calculator, I do the numerator first. So I'm going to go ahead and clear this. And so I put in -2, and then you're going to do one with a plus and one with a minus. So I'm actually going to start with the minus, and we're going to do second square root, and then 2 squared minus 4, and I'm just going to use parentheses like I've written down, -0.005, close it, open another, and this one is 5, and then close it, and that is our complete numerator. So I'm going to hit enter. Oh, but I have an extra parenthesis in there, so let me take that last one off. So I'm going to hit enter to get that full numerator, and then I'm going to divide by, and then in parentheses, 2 times -0.005. So you have to keep that the denominator group together. And then you'll see I have a positive value. I have 402.48, and we could just go ahead and round that to 402. Now, if I do this again but substitute plus here, I will actually get a negative value. So you can see here I have the 402.48. If I try it again with using a plus, I'll get the -0.2.48. We can use it for graphing purposes, but in the context of the problem, it doesn't make sense to have a negative number for x. So the 402 is what I'm looking for. So to answer the question, how far does it travel before it hits the ground? It hits the ground at about 402 feet. So if I want to go ahead and plot that, it's right here, this last point here. And then again, to use your calculator, if we go back to our graph, if we do second calc and choose 0, I can slide all the way over. And I want to be on the left side of it and above the x-axis. I need to get on the other side of it and be below the x-axis, and I'll hit enter and hit enter again, and then you'll see here I have the 402 again. And then the last question is asking me to go ahead and graph it, and then remember the last thing that we need to graph is our y-intercept. So that's what I have down here. It's our last thing, and this one's probably just easiest to plug in 0 for x. So if I plug in 0 for x, so remember that's how we find the y-intercept, I come up with 5. So that point is about right here, 0, 5. Remember to find a value on your calculator, any value for x. I can go ahead and choose a value, and I'm looking for when x is 0, and it will tell me that y is 5. So now I have all my points plotted on my graph, and then I'm going to do my best to make this rounded, and then I'm going to come back down, and then there is my graph.